Okay, welcome. So I want to now talk about how we can create a similar interactive bar plot using the native features of the Plotly package. So we don't need to first create a static ggplot and then convert that to an interactive plot. We can just create the plot entirely in Plotly without doing anything in ggplot. So if we can always open up a window to take a look at the help documentation. So if I do help Plotly, this works in RStudio as well. And I run this code cell. The difference is the help documentation opens up over here. So this tells us some of the various arguments. It doesn't tell us too much information about. This is just the package at large. The main function that we're going to use to create an interactive plot is plotly with an underscore between plot and ly. So let me run help on that. And that tells me more specifically, here's all of the arguments that we enter inside of the plotly function. And down below, it explains in more detail what each of those arguments are. But I'll kind of talk about the main ones together, but just know you can access help documentation to get a more complete picture. So the first thing you would need to enter into the plotly function, there's an underscore between them. Again, I won't say underscore every time. But the first thing we need to enter is the data. And one difference is that in order to access a variable inside of the data frame, we use this squiggle tilde before the name of the variable, as opposed to like a dollar sign. So a tilde before the variable name, that indicates a variable within the data frame. Then we need to enter a type in our plot, such as do we want a bar plot or a histogram or a box or a violin or a scatter. And so if we don't enter a type, it will do its best to guess what type of graph we want based on the data types of the variables, if they're numeric or categorical, for example. But it's always best for us to enter the type ourselves rather than have the Plotly package guess which type of plot we want to use. The next thing we do is we enter in arguments that we specify as the attributes. So this would be things like X and Y to map something to the X or the Y axis. So these are the Plotly equivalent of aesthetics. They're called attributes in Plotly. And then a couple of other arguments that are useful in the Plotly package. There is the split argument, and this is used to create multiple traces, one for each value of a discrete variable, like a categorical variable. And this is very similar to the group argument in ggplot2. If we have a categorical variable, we can create a different trace value for each class of the categorical variable, and then it's going to create a different plot for each class of the categorical variable. But you can do some research more about that. That is an argument which is often used. And then there are other arguments that we can enter, like the color and the value for alpha. These are the same alpha values that we used in ggplot2. So this controls the transparency of the graphic. 0 is fully transparent, 1 is fully opaque, and you can go anywhere in between those. So that's kind of the main arguments that are like the data-driven arguments in creating an interactive graphic. And then you can add other layers to that, similar to like the plus that we had with ggplot. With Plotly, we use add functions. And we can customize the layout, which is like more cosmetic changes using the layout as well. Okay, so let's see how we could create this same interactive plot for the species of penguins entirely in the plotly function. So if I want to do this in plotly, my X is going to be species and my Y should be on the vertical axis. I want to plot the count, how many species are in, what number do I associate with each species? What's the frequency? That is not already a variable in the penguins data frame. So one thing that was nice with ggplot, right? When we created this plot, we just needed one aesthetic X. And then it does some calculations for us. It counted how many observations were in each species and then plotted that value on the vertical axis. Plotly does not do that. So we need to calculate the value for Y ourselves. So that means before I can use Plotly, I need to first have a data frame that has 1, 2, 3 species. And then for each of those species, I need to calculate how many observations were there. So one way that I can do this is using the dplyr package. And just note that I have already loaded the tidyverse back here. And that means I've loaded the dplyr package. Just be sure that you load the dplyr package in order to run this code cell down here. So I'm going to use the dplyr package to create this table. So I want to go into the penguins data frame. I want to group by species. And then I want to summarize each value in that data frame for each of the 3 species. This is going to calculate the number of observations in that species for that species. And then finally, we can print that output to the screen. And this did not display because I have include equals false. In the first HTML version that I created, I didn't want to include this answer, but now I'm going to delete this and run it again. And now I can see the output. So we needed to delete that include false from the code cell in order for us to actually see the output generated here. But now this creates a data frame where I've got just my 3 species. And for each species, I have calculated how many times does that species occur in the data frame. And now from this information, I'm going to create my interactive box plot. So I had an extra step here that I needed to calculate these counts that I didn't have to do with the ggplot function. This all automatically calculated the counts and plotted them on the vertical axis. Okay, so now I've got my data frame, which is no longer penguins. It's now called species counts. And then I've got 3 observations and 1 variable for each species, which is just the frequency. So once I've got my frequency table, I can now use that to construct an interactive bar plot. So the first thing I need to enter is the data. And again, I'm not using the penguins data frame because that didn't have this summary. So I needed to calculate that summarized data and store it to species counts. So that's my data. And first of all, the function is plot underscore Lee. My first input is species counts. Then I want to input what attribute is getting mapped to the x-axis, and that's the species. And I indicate that this is a variable from my data frame with the tilde. Next, I would enter what is being mapped to the y attribute, and that's the frequencies that I just calculated in species counts, then I would specify what type of plot to create, which is a bar plot. And so I don't need to specify that last type. If I don't, it's going to guess what type to use. I don't know if it will guess correctly. It did. So without the type, it did know to create a bar plot. But it's safer for us to indicate the type in the code cell so that it doesn't guess for us. But this created the same exact plot. This plot is different from the plot that we created in the first method. The formatting is a little bit different. So that is a little bit of a distinction there. But I can hover over it, and it does tell me various features of the graph, like exactly how tall is each bar. And just like before, we could kind of zoom in on different parts of the graph if we want to. We can pan around the graph if we want to as well. So this has the same sort of interactive components that our previous graph had, but there's really no need to fiddle around with this plot since the default plot looks pretty nice. So the main interactive feature here is that we can see there are 152 Adelie penguins, exactly 68 chinstrap, 124 Gen 2. And if we wanted to zoom in on certain other aspects of this graph, we certainly could using the menu up here.